All right, talk me through this. It says use the log properties to expand the logs completely. That means we don't want exponents, right? So notice division means what? Subtraction, and you have a y to the second power. So this is, you could break it up like this if this helps you to see it. Log base 3 of y squared minus log base 3 of x, but you need to move this out front still. So it's going to be 2 log base 3 of y minus log base 3 of x. Questions on that? Are you getting the hang of this exponent thing moving out in front? We see that a lot, right? All right, number 2, log 3 times the square root of a. This looks a lot like one of the ones we just did in today's lesson. Similar, anyway. So if you're going to break it up first, what operation are we doing? We gotta add because we're multiplying, right? So log 3 plus log rad a. Log rad a is better written as log a to what power? The 1/2 power. Okay. So then simplify that again. What does that become? 1/2 log a. And then don't forget about that log 3 that's out in front. Questions on that? Okay. Here's our natural log. It's not an oh no, it's a beautiful thing. Okay, so for this one, you have the exponent. I would move that exponent out in front right off the bat. So it's 2 times the natural log of, we're going to break this up now inside, natural log of what? 5 plus the natural log of x, okay? So you can write it like that, or you could write it like this. Oops. Both of those would be acceptable to me.
Is it fine if we write the L in like the actual L and not cursive?
You may write, yes, you don't have to write your L's cursive. I just do it so that I don't want you thinking this is 21 n to the 5th, right? But yeah, you don't have to write it as cursive. Totally fine. All right, number 4 here. Now we're writing it as a single log. So we're doing the opposite of what we just did. It was expand it. Now we're saying simplify it. Bring it down to 1 log. So we know it's log base 5 of what? X to the 4th times y. Okay, you're multiplying. So x to the 4th times y. And that's your answer. Okay. What about this one? Number 5. It's going to be division. What's on top? So we know it's a log out in front. On top is 3. What's on bottom? B to the 4th. You guys are so good. All right. Some natural logs here. Again, subtraction. So we're doing division. Don't let the natural log freak you out. It's the same thing. It's just not log, it's ln. What's on top? X squared on top and y to the 5th on bottom. And that's your answer. Okay? Moving right along. Evaluate, right? You should get a number answer on these. And there's 2 ways you could do this. You could think of it in terms of exponent, or you can think of it in terms of properties. I don't care which one you do. If you think of it in terms of exponents, you're basically asking yourself the question, 4 to what power equals 64, and 4 to what power equals 4, and then subtract those things. If you think of it with the properties, you're saying log base 4, we're doing subtraction, so that's going to be division of 64 divided by 4. So that's log base 4. My 4s never look like 4s. I don't know why it doesn't want to turn that corner. I'm really sorry. So log base 4 of 16 And now you ask yourself the question, 4 to what power equals 16? And that is what? 2, okay? So I don't care if you think of it like this, 4 to what power equals 64? That's 3. 4 to what power equals 4? That's 1. And then do the subtraction. 3 minus 1 is 2. Okay, you're gonna get the same answer. Use properties or use exponents. Doesn't matter. You pick the one that makes sense to you. Okay? Sometimes you won't get to choose. Sometimes it's just not nice. Like this one, exponents doesn't work great. 6 to what power equals 2? That's not pretty. But what is pretty, what do you do with these numbers? Multiply them. Log base 6 of 36 is saying 6 to what power equals 36? 2. 6 to the second power is 36. Okay, number 9. So you have that 1/2 out in front, okay? If we make that an exponent, it's essentially log base 5 of 1 to the 1/2 power. 1 to the 1/2 power is really saying it what? The square root of 1. So log base 5 times the square root of 1. What's the square root of 1? 1. So essentially what we're saying is log base 5 of 1 minus, sorry, I'm really writing this the long way. You don't have to write it this way. This would be log base 5 of 5 to the second power, right? Which is log base 5 of 25. 5 to what power would get you 25? 2. Oh, I simplified already though. Let's not do that. Sorry. So we're going to say log base 5 to the first power minus log base 5 of 25. Break that down into one log. Log base 5, what do we need to do with it? Dividing. 1 over 25. So 5 to what power gets you 1/25? -2. 5 to the negative second power. Yes, ma'am.
Could we have also done log base 5 of 1 is 0 and log base 5 is 25?
Yep. Which would have been way easier, right? I don't know why I didn't do it that way. But yes, you can do it that way. Yes. Why did it change to 1? Because the square root of 1 is 1, right? So just simplify it. Yes. It's all good. Okay, number 10. Log base 5 of 1. 0. 5 to the 0 power is 1. There's Lenny. 1. Good job. Number 12. 5 times the natural log of e to the 10th. Put the 10 right out in front. So you're saying 10 times 5 times the natural log of e. There's our friend Lenny again. What is that? 50. 10 times 5 times 1 is 50. Right? This guy is just 1. 10 times 5 times 1.
Were we not supposed to use our calculator on the first portion?
Right. So on the quiz, there's going to be a non-calculator portion just like we did before. Okay? Make sure you can do that stuff without. This one you can use though. Do you remember this property? How do you solve this? Log 30 divided by log 5, right? The base is the one that goes on the base, the bottom, okay? So log 30 divided by log 5, don't forget that parenthesis. You get 2.1133 would be 4 decimal places.
What was the property for number 13?
It said if you have, like, I don't remember what letters I used. Say it was log base b of m. Was it that?
Yeah.
You do log of m divided by log of b. Okay, solve the exponential equations, rounds your answers to 3 decimal places. What do we do here?
Add the log.
Take the log of both sides. So log 5, I'm going to move that 2x out in front. So 2x log 5 equals log 41. Okay, if you want to do that in 2 separate steps, do it in 2 separate steps. That's totally fine. Now what do you do? Divide by log 5. Divide by log 5. Parentheses matter, right? Keep those parentheses going. So log 41 divided by log 5, you get 2x equals, whatever that comes out to, 2.3074. And then divide by 2. So x is approximately 1.154 if we're doing 3 decimal places here. Okay? What do you do for 15?
Divide by 7.
Isolate. You got to divide by 7 first. So you get e to the 4x equals 4. Then what? Take the natural log, right? Whenever it's an e, that's a natural log. So take the natural log of, e to the 4x. Ignore that, that's nothing. Equals the natural log of 4. Take that 4x, bring it out in front. So it's 4x times Lenny, that's a 1, equals the natural log of 4. Okay, so don't let that 1 throw you off. What do you do? Divide by 4. And again, parentheses if you're not going to hit enter in between. The natural log of 4, parentheses, divided by 4, and you should get 0.347. Am I pacing this okay for you? All right, solve the log equation, round your answers to 3 decimal places. We're trying to solve here. What do we do first? Move that 2, right? So we're going to take that here. So it's going to be x squared. Then it's subtraction. What do you do with subtraction? Division. So it's going to be 1 log, single log, x squared on top, 3.5 on bottom, equals 2. And I feel like this is one where people are going to forget the next step a lot. What do you do? 10 to the second power, right? Set it up as an exponential. So there's a 10 here. So you take 10 to the second power equals this expression, x squared divided by 3.5. Okay, what do you do next? Multiply by 3.5 on both sides. Okay, so we have x squared equals 3.5 times 100, 10 squared, would be 350. Okay, then what? Square root it. What happens when you square root? You get 2 answers, but do we want 2 answers here? No, because you can't take negative log. So you get x is approximately 18.708. So far, so good? 17. What do you do? Isolate?
No.
It's already isolated, right? The parentheses means we're isolated. So how do we set it up?
10 to the second equals.
Right. There's a 10 here, okay? Set it up in exponential form. 10 to the second power equals x minus 12. What do you do?
Add 12.
Add 12. Okay, so this is 100 plus 12. What?
That was easy.
Yes. Very easy. Simple, simple. We like those ones, right? All right. Where'd we go? There we go. Natural log of x plus 2 equals 5. what do you do?
Set up an e to the fifth equals exponent.
Right. So there's this e down here. Set it up in exponential form. So e to the fifth power equals x plus 2. Just subtract 2. And again, you can just plug that into your calculator, but make sure you get out of the exponent. So second e to the fifth power, but then arrow over and subtract 2. And you should get 146.413. Okay, last thing. Says a school's population is increasing by 10% each year. If the population is 725 students now, when will it be 900? Okay, the exponential equation, let's just set up our equation for now. It's going to be y equals what? 725, your starting amount, okay, times what? I heard it, Juliana, what'd you say? 1.1. If it's growing by 10%, it's 110%, right? This is the one where you go 1 plus the 0.1. So this would be 1.1, oops, to the t or the x, whatever you want to call it. The question is, when will it be 900? Okay, so we're trying to figure out time, when. So we're going to plug in a 900 here. 900 equals 725 times 1.1 to the t power. We're going to divide by 725 then. So we get, what does that come out to? 1.2414 equals 1.1 to the t power. Okay, how do you solve that? Take the log of both sides. Good. So log 1.2414 equals log 1.1 t or x. That's going to go out in front. So it's log 1.2414 equals t log 1.1. And then what? Divide with parentheses, right? Divide by log 1.1, divide by log 1.1, so this is gone. T comes out to, when you plug that in with that parenthesis or hit enter, you get, did we say word around here? 4 decimal places. 2688?
Yeah.
2688. And that was time, right? They were talking about each year, so 2.2688 years is when we'll hit 900. Questions?